Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Carbocation stability is determined by resonance delocalization, aromaticity, and hybridization of the cationic center. Moving on to the next step. Identify each carbocation's structural context. Option A. An indene-type system where the positive charge is on the sp3 carbon of the 5-membered ring at the benzylic allylic position. The 5-membered ring has one double bond, so this is an allylic carbocation also conjugated with the benzene ring. Option B. An indene-type system where the positive charge is at the ring junction, bridgehead carbon connecting benzene and cyclopentene. This position is highly strained and the cation cannot be stabilized well due to Brett-like constraints on resonance. Option C. An indene-type system where the 5-membered ring is fully conjugated, cyclopentadiene-like, and the positive charge is at C2 of the 5-membered ring. With the benzene ring fused, and the 5-membered ring having maximum unsaturation, the cationic carbon is part of an extended conjugated system. Specifically, this creates a fluorenyl type or indene cation where the positive charge is on a carbon within a fully conjugated bicyclic framework. This corresponds to a cyclopropenyl tropylim analogous aromatic stabilization scenario. The 5-membered ring with two double bonds and a carbocation gives a cyclopentadienyl cation fused to benzene. However, importantly, the positive charge here is on a carbon flanked by double bonds in the 5-membered ring, giving maximum delocalization across the entire fused bicyclic pi system, 9 carbons in conjugation, similar to indene cation with full aromatic delocalization. Option D. An indene system, saturated 5-membered ring fused to benzene, with positive charge at benzylic position. This gives only benzylic stabilization. Moving on to the next step. Compare stability. Option D. Simple benzylic carbocation, moderate stability. Option A. Benzylic plus allylic, conjugated with both benzene and the double bond in 5-membered ring, better than D. Option B. Bridgehead carbocation, very unstable due to geometric constraints. Option C. The carbocation is at a position in the 5-membered ring that is fully conjugated with the fused benzene ring. This creates a system where the positive charge is delocalized over the entire bicyclic conjugated framework. The structure resembles an indene cation with maximum pi delocalization. The cation at C2 of the cyclopentadiene ring fused to benzene allows delocalization across all 9 carbons of the fused ring system, providing the greatest resonance stabilization. And for the final step, why other options fail? B. Fails due to bridgehead strain limiting orbital overlap. A and D have limited conjugation compared to C. C provides the most extensive resonance delocalization through the fully conjugated fused bicyclic system. Therefore, the correct answer is C. Therefore, the correct answer is option C.